All right, this lecture is on Swartz's regularity account of the laws of nature. It's inspired by Hume. Um, so I maybe could have combined this lecture and the Hume lecture into one, um, but I don't know, I didn't. So this one should be relatively short as well, and it's sort of a more modern, more formalized account of what's Hume's getting at, right? And there are still definitely philosophers today, like Swartz and others, who believe this account of what it is to be a law of nature. So let's get into what that is. So first of all, Swartz is sort of against his position is kind of defined somewhat in terms of his opponents, and his opponents are people who think that there's anything more to the laws of nature than just a description of what happens. Um, and if you read the article, he sort of quotes a lot of people, physicists and other people, who sort of implicitly use some terms that seem to imply that laws of nature have some sort of active force, that they do something, that they govern, right, the movements of objects in the world, or they govern sort of the biology of animals, or they make things happen in some way. Um, and that if it's really what you think, the laws of nature are sort of moving things around. Um, it's kind of sort of deeply weird and mysterious how that could be, or what sort of thing a law is that actually sort of intervenes and moves things around, right? Um, so he's going to sort of like try to make more clear and precise the weirdness involved in that notion, and then argue that it's not necessary, right? It's weird and it's hard to define and it's not helpful and you don't need it, basically. So instead, he's going to argue that laws of nature are just descriptions of regularities in nature. We observe, right, things happening. We observe that when we drop objects, they fall down. We observe that when you feed certain sorts of creatures certain substances, they die or they um, thrive or whatever, right? And we see it over and over. These are regularities. And he says that's all law is. If you observe a regularity enough times, and there's a few more conditions to distinguish laws from just sort of like things that aren't intuitively don't quite count as laws, but basically they're just going to be regularities that are observed over and over. So again, definitely his account is inspired by Hume, right? Because Hume was trying to figure out on what sort of basis you could claim that there's anything like uh, forces, right, or necessity involved in the things we observe. And we recall that Hume sort of argued this from an empiricist viewpoint, right? He thought that, well, any concepts that you have will have to be ultimately derived from the senses, and he argued, like, by what sense do we ever see any sort of necessary connections or forces or things like that? Um, so, of course, that line of argument from Hume sort of relied on your being an empiricist like him, and not everybody is. So I think Swartz's account comes at it from a different angle, and even if you don't agree that the only concepts we can have are concepts that sort of come from our senses, you could still potentially agree with Swartz that a regularity account is the best account of laws. So one thing Swartz does up front, which we'll also notice later in the Dretske article, so we should just sort of point it out, even though it's not going to play sort of a crucial role in his argument right now. But he wants to talk about two different types of laws, right? So there's scientific laws, and those are the things that scientists create, right? They're sentences, right, or even equations, and um, they describe natural laws, they state laws, but those laws that scientists come up with and are potentially sometimes wrong and have to be modified and stuff. Um, Swartz wants to say that's a different thing than actual laws of nature, which he calls physical laws, right? Now those are just eternal; they've always been, and we try to discover them and try to describe them with our scientific laws, and we may or may not be successful. Um, but physical laws just are, right? And scientific laws are products of human uh, ingenuity. Um, okay, so He's not interested in studying scientific laws. You could do that. That would be more of a sociological endeavor, right? To try to see what's going on and how scientists develop their laws. Um, Again, he cares about laws in the world, and he doesn't want you to mistake the term physical law for meaning only laws of physics. So he just means the basic laws that are in the world. Um, so it could be law of economics or psychology, biology, whatever. Okay, so here is Swartz's account of what counts as a law. And this turns out to be a regularity count because it doesn't really give too many extra conditions. Certainly no conditions that say that there has to be some sort of um, right necessitation between the cause and effect in these laws. So he says all it takes to be a physical law is um, it's going to got to be true, right, and not just sort of temporarily true or true in a particular location. This has to be true for all time and for all place. Um, it's going to take the form of a generalization, right? So all F's are G's, um, right? All objects accelerate towards the Earth at 9.81 meters per second squared. They could be statistical generalizations, so all samples of radium will decay with a certain probability, right, um, over a certain amount of time. Uh, these are the two types of laws we've encountered, particularly in week 2, when we were seeing accounts of scientific explanation. We saw a few examples of the laws, and they're generalizations, which you can then sort of from them deduce particular cases, right? Um, 3, they're going to be purely descriptive. So there's not going to be laws about Nate Greeley, right? There's not going to be laws about any particular person or any particular object, right? They're going to be general claims that say things with this sort of property will tend to have this other sort of property, right? But it's not picking out any particular object by name. And they will tend to be conditional. We've seen this um, in both statistical and uh, other types of laws, but it's most obvious in those ones that take the form of universal generalizations, right? For all x, if fx, then gx, right? That little arrow, that's a conditional. Um, Even the statistical laws will be of that kind, right? They sort of say if a certain subject is, if a certain object is a sample of uranium, then it will decay with a certain probability in a certain time. And finally, it should be contingent. So all that means is it shouldn't be a logical truth, right? And so it shouldn't be something like all bachelors are unmarried or 2 plus 2 equals 4, right? Those sorts of statements are true in virtue of the meanings of the terms involved. Um, and so physical laws are going to be contingent. They could be otherwise. It's conceivable, right, that the acceleration of gravity could be something besides 9.81 meters per second squared. Not a contradiction to imagine that to be the case. Um, so that's what it means that these laws are contingent. Okay, and then Swartz says if you got these 5 things, you got a law, right? You don't need anything extra. You don't need to say anything about how they govern or necessitate the things they describe, right? These are just true generalizations. So now he wants to argue a little bit about what's so weird about thinking that you need anything more than those conditions, right? That you need laws to somehow govern or necessitate or make things happen, right? And the way he sort of gets at the weirdness is in terms of our count of truth, right? So if you've taken any philosophy of language, this should be familiar to you. If not, it's no big deal. It should be pretty straightforward. So when we want to define truth, it's usually defined in terms of a relation between sentences. So the sorts of things that can be true or false are sentences, right? So objects in the world aren't true or false. They just are what they are. Um, but it's a sentence or a proposition that's expressed that I can then say uh, either that's true or it's not true. Um, and there's different accounts of truth, right? But Swartz just says, look, a sentence is true if the fact that it describes obtains or is the case. So um, if I produce the sentence, sky is blue, right? How do we determine if that's true? Well, we look at the actual sky, right? Don't look at the sentence, but look at the actual sky. And if it's blue, then the sentence is true, right? So pretty straightforward. And so the way we express this is by putting sentence in these little single quotes here. You see, so we have in single quotes, the charge on each electron is negative 1.6 times 10 to the negative 19th coulombs, right? And we want to say that's true if and only if it is in fact the case that the charge on each electron is negative 1.6 times 10 to the negative 19th coulombs. Now that looks a little weird. The difference is, right, we have on the sort of left side of the sentence in the little scare quotes, we call them, that's a sentence. We say that sentence is true if the world is the way it describes, right? Um, and that's sort of the most minimal sort of account of truth, right? Doesn't commit to too much, and it seems agreeable to most people. Um, and what Swartz wants to say is that if you think laws govern, um, you have flipped this truth relation upside down in a very weird way, right? So what you're essentially saying, if you think that laws make it the case, right, that electrons have the charge they have, you're saying that the reason electron has a charge of negative 1.6 times 10 to the negative 19 coulombs is because there is a law somewhere to the effect that, in quotes, electrons have a charge of negative 1.6 times 10 to the 19th coulombs, right? So the world is the way it is because of some law, right? Now he's sort of comparing the law to a sentence, and again, he did make that distinction between physical laws and scientific laws. Scientific laws are sentences, physical laws are something else. Um, so what he's not saying is that because I write the sentence, that makes it the case that electrons have that charge, but he is saying that laws, according to this sort of we'll call the necessitarian view, which is not his view, right? The view he opposes. On this account, they are some kind of weird entities. They're sort of like sentences, but maybe they're not exactly sentences. Um, and they make the world the way it is. He says it's very weird. It seems like a mirror image of the normal truth relation. He's not quite sure what to make of it, and it's really on the necessitarian to try to make sense of it. And we will see Dretsky, right, will give us an account of what that means. Okay, so, right, given this point that he's made about the truth relation, it seems that governing laws are sort of special propositions, and a proposition is different from a sentence, right? A proposition, again, there's different accounts of what propositions are. A proposition can just be a sort of a state of the world, or maybe some abstract entity, right? But at any rate, um, laws are something like that, some kind of proposition that doesn't actually derive its truth from the way the world is. Instead, it's a proposition that makes the world the way it is, forces nature to behave in certain ways. And Swartz wants to ask, is this really the case, right? Are there really two sorts of propositions, ones that describe the world and ones that govern the world? If there were, the ones that govern would be these necessary propositions, we'll call them laws, right? So we're going to call someone who believes in these things a necessitarian. Um, and these sorts of laws, these propositions, if they existed, um, would be true even if the world were very different, right? So right now we have certain laws about, I don't know, I just picked bear biology, right? I don't really know much about bear biology. Presumably they have some laws. Or you could say, laws of human biology, right? And if those are truly laws, that means that on this necessitarian view, they would still be laws even if actually there weren't any bears or weren't any humans, right, for them to describe. Um, Seems a little strange, right? Uh, but that's sort of like something that follows if you're a necessitarian. Um, so, as he describes it, they're autonomous and subjunctive, right? They don't derive their truth or their power from the way the world is. They would be true even if the world was different. They're sort of above and beyond the world. And he thinks this is odd and frankly false. So he says, after trying to sort of point out the weirdness of the necessitarian view, um, he then tries to convince us that we don't need it, right? We can get by with less. And he describes this as a sort of Gestalt switch, right? So if you don't know Gestalt, right over here we have this picture of the duck rabbit, and if you look at it In one way, you have a duck, right? The beak being on the left. You can kind of look at it another way, and all of a sudden it will look like a rabbit if you look at the on the left as being the rabbit's ears, right? And when it kind of switches, sort of like when you're viewing it as a duck versus viewing it as a rabbit, that's sort of called a Gestalt switch. It sort of switches the frame through which you're viewing the thing. Okay, so if you want to be, he says we should be regularity theorists because uh, first of all, we only if you want to do that, you only need one theory of truth, right? You have the way the world is, you have sentences that describe it, and that's it. You don't need these extra weird autonomous propositions that supposedly govern the world. You can just get rid of those because they don't really make much sense anyways. Uh, and you can still believe everything you already believe about the Earth, right? You can say, oh, the universe is orderly, right? All you have to do is you don't have to make the extra assumption that there's something necessary about that orderliness or that there's something else that makes the world orderly. Um, because he says, how does that help us understand anything? Like, for an example, if you ask me, if I tell you, oh yeah, electrons have charge of uh, what was it, negative 1.6 times 10 to the negative 19 coulombs. You ask me, oh, why is that the case? And I say, oh, well, because it's a law that electrons have a charge of negative 1.6 times 10 to the 19 coulombs. Is that going to help you understand anything, right? Not really, right? It's just saying how the world is and then adding, oh, and it's necessary and it's a law. Okay, not very explanatory, extra sort of metaphysically mysterious. So why bother with it, right? Just stick with the basic regularities, the descriptions of the world. And he sort of wraps up with a little cost benefit analysis. He says, well, take your pick. Do you want to believe in governing laws? Do you want to be a necessitarian or do you want to be a regularity theorist? Well, here's sort of the pluses and minuses of each. And he thinks that if you add up the pros and cons, you're going to favor regularity theory. So first of all, necessitarian laws don't have what he calls any theoretical virtues, right? So theoretical virtues, there's a tendency to want to pick a theory that's like the simplest, right? Makes sense with the fewest assumptions and helps sort of amplify our understanding of the world, help makes the best predictions, right? There's sort of ways you weigh whether one theory is better than another. And he thinks that necessitarian laws don't have any of these virtues. They don't really help us understand anything more, right? For example, the example we just said with if you ask me why do electrons have that charge, and I just say, well, it's a law that they do, really, right, extending my understanding in any useful way. So they're just sort of extra machinery, and they sort of complicate things, right? So why not go for the simpler, sleeker theory? Um, there's other sort of advantages as well of the regularity account. He thinks it's good to get rid of this sort of extra metaphysical baggage. So he looks at the history of science. He says there have been times where people were tempted to posit things like vital forces. We wanted to explain life, right? Why are some beings alive and some aren't? And so at one point we thought, oh, well, there's a special force called a vital force, and that's what sort of animates living things and makes them different from rocks or whatever. Um, Eventually, when we understood sort of biology and 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 what's involved, we didn't need that force, right? We were able to explain it without. Natural place is another thing. This is Aristotelian sort of physics, right? He thought, oh, well, right, things fall to the ground because sort of that's their natural place, right? And things tend to move towards their natural place. When we got a better understanding of physics and stuff, we didn't really need to talk about natural places anymore. Things just do what they do, and that was enough. So he thinks that this governing notion of laws is another of these sort of things that people have felt like they had to plug in, but you don't really need to. When you understand things better, you can just get rid of them. Number two, regularity theory puts laws in the special sciences on the same footing as laws in physics and chemistry, right? So now this he claims or lays on the necessitarians. He thinks that they think that laws of physics are going to be the only fundamental laws, and that right, those are the basic laws that run everything, and then everything else is going to be a consequence of that. Um, And we're going to talk more about this in week 5, actually, about reduction of theories, right? The idea that all the sciences could be reduced to physics, and those are the most basic laws. And he rightly worries that that may not be possible, and we'll see much more. We'll see authors that explain in detail why it's a tough task to think that you could reduce economics and psychology and all this stuff down to physics. And so Swartz says, if you're a regularity theorist, you don't have to worry about that. You don't have to worry about reduction of everything to physics. Because all you have to do is look at the regularities, right? If there's irregularities that you can observe in psychology or economics, then it's a law, right? You don't have to worry about it, whether those laws somehow derive their power, their governing power from more fundamental laws. So that frees you up. And finally, if you're a regularity theorist, he thinks you can solve the problem of free will. So I don't know if you've taken maybe Intro to Philosophy or something where we talk about the problem of free will, but in a nutshell, the idea is if you think everything is governed by the law of physics, then that kind of means that if you knew the initial conditions of the universe at the Big Bang and and you knew the laws that govern the motion of every single particle, then actually you would know at that moment every choice I would ever make, right? Because I'm just made of particles, right? I'm just operating according to the law of physics. Um, so do I even have free will? Do I even get to make choices, or was it already decided at the Big Bang? That's a very short sort of statement of like the problem of free will. He says, well, if you're a regularity theorist, you don't have to worry about that, right? You don't have to worry about these governing laws that are forcing you to decide what you decide. Instead, laws are just descriptions of what happens, right? And they leave room for you to make your own choices. Okay, so that is Swartz's account of regularity theory. And in the next lecture, we'll talk about some objections to regularity theory from Armstrong. Um, Armstrong is one of the proponents of necessitarianism, but we're not going to read his account of necessitarianism because it was hard to read. I chose Dretske instead because he's very much more pleasant to read. But we are going to talk about Armstrong because he presents some good objections to regularity theory.